大家午安。我知道这个时间是最难的，大家是最想睡午觉的时候，所以我现在今天讲的是 Azure Machine Learning。那这个 Data Science 比较多名词，所以我会用英文的去讲，因为我中文真的是太烂了。可是我想先问一下大家，现在是谁是一个 Data Scientist？ 现在是大部分的工作是 Data Scientist， 有多少人？OK， 有一些 OK。那在语言方面的话，是比较多是谁会写 Python？ 现在是谁会 Python？ 任何 Python 都会 OK。那如果是 R 的话呢？是 R 也有一些 OK。好，谢谢，我只是想了解一下。那我先播一下这个 video， 先介绍一下这个 Azure Machine Learning。
My team's purpose is to connect people with data and technology, and at the heart of that is reservoir and base management, where we have a core focus on improving our gas portfolio while reducing our carbon emissions.
Before the workflow that we had in place, each region of the world was working in a completely different way.
One of the first things we did was we took the solution and we put it onto the Azure cloud. In parallel to that, we started to build our machine learning model.
Now we have a standard procedure. Everybody works the same way.
It's essentially a few extra lines of code to instantiate the SDK in a notebook for a data scientist. Or Microsoft Automated Machine Learning, who are looking at building 9,000 parallel models. That type of build is just not possible without automated machine learning.
Being able to use the machine learning model to predict the recovery factor down to seconds. We've seen both cost savings but improved decisions.
The business is going through enormous digital transformation, and that requires much more sophisticated software to allow people to move to much higher value tasks.
As a company, it's allowing us to open up opportunities that we never knew existed.
So as we saw in the video, there's a lot of problems with machine learning today. And today I'm going to talk about an overview of just the machine learning platform on top of Azure, starting with codeless machine learning. So for those of you who may not know Python, who may not know R, but want to get started with machine learning, I'll talk about a way in which you would be able to do it without even having to write one line of code. And then for those of you who want to do a little bit more, in addition to that, we also have what's called automated machine learning. How are you able to search through the space of different classifiers, given the data that you have, to be able to find a classifier or find a forecasting model that would be able to work well for you in a more automated fashion, so you don't have to spend so much time having to do it manually. I'll talk about MLOps because in the machine learning and data science workflow, we don't see the rigor that we see in software development today. I imagine most of you here are very technical, probably many of you are software developers, and you're probably very familiar with all of the tools for software development, source control and unit tests and all the workflows and the DevOps that you have to do to make sure that your code is of good quality, it's shareable, and all of these things are not things that you see in machine learning today. And so I'll talk about the work that we're doing with MLOps. And finally, just a few trends in what we're seeing in the machine learning and the AI space with Onyx, the Open Neural Network Exchange format, how we're able to have a common unified format to represent machine learning AI models, and then to be able to run it on the Onyx runtime. Because for those of you who are familiar with some of the frameworks in AI, whether it's going to be TensorFlow or PyTorch or all the different frameworks out there, there needs to be some way of representing that, or else it's just going to get too complicated too quickly. So this will be an overview of the machine learning platform on Azure in terms of the custom models that you'll be able to build. So as we look at AI and machine learning all up, one of the things is from the top is available is the sophisticated pre-trained models that I talked about yesterday with the cognitive services. So the cognitive services are just a set of AI models that are accessible via an API. You can send data to the API, such as images or voice or speech or text, and it's able to process that data and to be able to identify objects in images or identify faces in the image or do real-time translation or transcription. These are things that are available today with the cognitive services. The machine learning platform supports all of the open source frameworks. So again, as I mentioned, with PyTorch and TensorFlow and whatever framework that you like to use, you are able to do that on the Azure Machine Learning platform. The services, for those of you who may be doing a lot of work in Spark, we have integration with Azure Databricks, and so now you can bring your Databricks workflow directly into Azure on your Spark cluster using Spark. And then all running on very powerful infrastructure, whether it's going to be CPUs, GPUs, or FPGAs. And so the models that you can build can run on these different types of chips. And tomorrow morning, I'll be talking about the work that we're doing to accelerate models on things like FPGAs or also ASICs to be able to make your AI models run faster. And then the models that you build are containerized in Docker containers, and that means these models can now run on any compute that can support Docker, whether it's going to be in the cloud, on the edge, or even your on-prem server, because it's, at the end of the day, it's a Docker container. So this is just an overview of the various components of the machine learning platform. So when I think about it in a different way of looking at the AI space and what we want to support you in the platform, the first axis is what kind of AI and machine learning do you want to run? And so we talked about the pre-built models, everything from pre-built to custom. So you can use the cognitive services for your pre-built models. You can create and train your own custom models. You can do that. So what kind of AI machine learning do you want to run? The next thing is, where do you want to run your machine learning? Where do you want to run your AI? Do you want to run it in the cloud, basically scalable worldwide? Do you want to run it on the heavy edge? Heavy edge are basically server-grade machines or PCs that can support CPUs, GPUs, or FPGAs? Or do you want to run it on the light edge, things like intelligent cameras? And so where you want to run the AI is something that we can support in the different places where you can run that. The next question is, how do you want to run the AI? Do you want to run it on a CPU? CPUs are relatively cheap. They can run ML, they can run AI, but then you might get to a point in which a CPU may not be able to handle the workload, especially if you're doing a lot of deep learning applications. But CPUs are available for you to run your models on. Do you want to run it on a GPU? GPUs are great at high throughput deep neural networks, and so one of the things you have to consider is also the cost of GPUs. Do you want to run it on an FPGA, where you want to be able to accelerate that model on a specialized FPGA chip, where we want to be models that are fast and also inexpensive? Or do you want to run it on an ASIC? And so the whole idea here is anywhere in this space is a place in which we want to be able to support you. So for example, you want to run the custom-built model that you deployed in the cloud on a GPU. We can support you there. Maybe you have a custom-built model that you've accelerated on an FPGA on a server edge device on the heavy edge. We can support you there. Or another model that you want to run on the light edge. It's something that we can support you. So the idea here is we've built a platform so that you can be anywhere in the space, so that the types of AI, what kind of AI do you want to run, where you want to run the AI, and how you want to run the AI is something that we can support you in being able to do. So the building blocks for a data science project, when you want to do data science, really begins with the models that you want to build and you want to train. So they could be your classical machine learning models, could be your deep neural networks with your AI models, but all of them require some form of hyperparameter tuning. And so that's another step in the process. After that is also all of your experimentations, the pipelines that you want to build, the pipelines where you are taking in data, where you are training that model, all of the things that you're doing there. And then the next question is, how are you going to deploy the model? How are you going to run that model in production so that it's able to take in the data and be able to give you the predictions back? And finally, how do you integrate it into a DevOps workflow? Because as data scientists, maybe all you care about is training a model and being able to deploy it and run it and just get some pretty decent or good results, and that's all you care about. But the business cares about a very rigorous workflow. The business needs to have confidence that the pipeline that you have, where the data is being ingested, where the results are being are created, and that goes to the next step of your line of business app. For example, all of these things have to be very, very rigorous and very production grade. So how do you do that integration with DevOps? So all of these building blocks are very, very important. So the Azure Machine Learning Service is a set of cloud services, and this is Azure Cloud Services that are accessible via a Python SDK. And this Python SDK enables you to do every step of that process, starting from preparing your data, to building the models, to training the models, all the way down to managing them, and then deploying them, and then being able to then integrate that into your CI/CD pipeline. So this is the Azure Machine Learning Service that you'll have access to. So let's start with a very, very simple data science problem, and we'll talk about the steps that are required and just some of the tools that are available to help you in that process. And so the question here is, you have a car. How much is this car worth? How do you build a machine learning model that will be able to predict how much this car is worth? So these are the three basic steps in doing something like that. You need to prepare your data, you need to build and train your model, and then you have to deploy that. So in terms of preparing the data, we have a data prep SDK that you can then take in your data and be able to prepare it and get it into a form in which you could use that. And then the next step is to build and train your model. And so your model, at the end of the day, is something that takes in a set of features. So for example, I want to consider what brand the car is, what year it was made, how many miles it has on the car already. These are the features that I will take in. My model will then predict how much this car is based on these features. So building and then training that. So the machine learning service enables you to do this through a variety of different ways. So for some of the developers out there who like the CLI, the command line interface, we have the machine learning CLI that's available. We also have a VS Code extension. So in Visual Studio Code, there's an Azure Machine Learning extension for you to be able to access these services. For those of you who like Jupyter Notebooks, using that, you also can just import the SDK into Jupyter Notebooks, and then also any other types of Python IDEs, whether it's going to be things like PyCharm or other IDEs of your choice. So the idea here is we want to meet you where you are. Instead of building a solution or product that we force you to have to use, we just have a Python SDK that enables you to use it directly. And then this is accessible. You can use your local machine if you want to train models on your local machine. You can scale it out with compute in the cloud, whether it's going to be VMs or cluster CPUs or GPU clusters in the cloud, and then also with Spark clusters, that's also available. So basically, as you go through your training steps, you'll get a model, it'll get some level of accuracy, and then the next step is basically being able to deploy it. And so what we do is we take your model file, and then we take it with all of its dependencies and put it into a Docker image, a Docker container. And then now that you have this Docker image, you can then run it on anything that can run Docker. So for example, you can run it in your on-prem deployment. You can run it on an IoT edge device. Basically, it's just a server or a PC that runs locally on-prem. It could be in Azure Container Instance, which can run containers very easily, or Azure Kubernetes clusters, where you want to be able to scale out the deployed model very, very easily. So all of these things are available for you to be able to run that model. And because it's Docker, Docker is just an open source, Docker is open source. You could take this model not only on everything that I listed here, you could take this model and run it on Google Cloud. You can run it on AWS. Of course, we hope you don't, but you can. It's okay. But it's just a Docker container that you can run anywhere that can support Docker. So in addition, we also have the integration into the various data stores because we get to talk about the fun parts of AI, where you take that model and where you can run it and do some very interesting things with it. But there's a whole other discussion on on the data itself, on all your data estate. So having a very modern data estate is also critically important. So just to summarize a little bit about just some of the things that we talked about, being able to help you boost your data science productivity, basically increasing that rate of experimentation, and then deploying and managing your models anywhere. So with all of the tools that we have with Azure Machine Learning. So let's talk about how we can make this a little bit more simple and streamlined. And we'll start first with the codeless experience. So basically, how do you create a machine learning model without any code? And so basically the visual interface, for those of you who've been using Azure Machine Learning for a while, it's just basically, you've probably been familiar with Azure Machine Learning Studio. And Studio is just that visual interface. But now what we've done is created that visual interface and run it on the set of services that I just described. So now you have a way of creating your own machine learning models without having to write any code. And then all of this just integrates with the machine learning platform. And so with the visual interface, you don't have to do any programming, you don't have to write any code. All you're doing is dragging in and dropping some modules. You're using the same compute resources here that you would use if you were to use the Python SDK. You can register the models and deploy these models as services. So let me just run through just to give you a quick overview of what that looks like. And all of this you can see in the Azure Machine Learning workspace. So here is the machine learning workspace in the Azure portal. And basically everything that you need is here. So we're going to go here into the visual interface. And here is the visual interface in terms of creating a model that will predict how much this car's value is. So first I have my data. You can have your different types of data sets. You can look at all the different data that you have. You might have your saved data sets. There's a lot of different types of other data sets, but you can add your own data set here. And then you can see now I have a data set. This is the raw data. And then I'm just doing some selecting of the columns, and I'll just look at the output of this module. And you can see here that this gives you some information or some visualization of that data. So for example, here are all the different makes of the cars, maybe number of doors. You can see 4 doors and 2 doors. How many cars have 4 doors? How many are 2 doors? The types of the body style. You know, let's see what other kinds of interesting things are here. How much horsepower it has. The mileage per gallon here on the city, or the mileage per gallon in the highway. But an easy way to just visualize the data if you wanted to get an idea of what the data set looks like. So now you have your data, and then here is just another module that helps you clean your missing data. What it's doing is it's removing missing value rows. So sometimes you might have data and it's not very clean. You might have some data that you might be missing some values. So in this case, when it goes through this module, it's removing those rows in which there are missing values. So now you can look at your data again, and it should be a little bit more clean, where data that there should not be any missing data now in this data set. So once I have my data clean, I'm going to split the data into a training set and a test set. So the idea behind machine learning is that you have to split that data set. That one data set you'll use to train with, and then you apply that model onto the test set. So in this case, this module is doing that. It's just giving me 70% of the data as my training set, 30% of the data as my test set, and I do that with a split data. And all of those modules can be found here. So for example, if you look back here, you can see, for example, I might want to, if I want to do split data, so you can see that module is here, and I just basically drag it onto here, for example. But that's the basic idea. So now that I have my split data, this is going to get a little bit complicated really quickly, but we'll just focus on this area. This is my training data set, my 70% of my training data set, and then this is my test set. So my training data is going to go into this train model, and I'm going to use a decision forest regression algorithm. So basically, there's lots of different algorithms that you can try for different machine learning applications. Here's one of them. And if I want to look at decision forest, for example, you can see here that if I just look at the different types of models in here, on the left, you can see under machine learning, all the different types of models here. If you want to do classification or clustering or regression, there's a bunch of different models that you can use. So I'm going to try a decision forest regression model. This model is going to be trained on the data set, the training set. So I will train this, and then the result is going to be a trained model. So this is after I train the model, I'm going to apply this trained model onto my test set. So remember up here, we had split the data, and this is the test set, that 30% of the data. And that is going to come into here. So I'm applying my trained model onto the test set, and then I'm going to get my result of how well my model works on that test set. So what I'm also doing in this graph is I'm comparing the performance of a decision forest regression model with a boosted decision tree regression model. So the same idea is here. Here's my boosted decision tree model. I'm training it with the training data. That's 70% of the data that I'm going to use for training. And then this trained model will be applied to my test set, just so I can see how good that trained model is. And the whole point of this is the whole idea is you want to make sure that your machine learning model is very robust and that it's going to work on data that it's never seen before. So imagine you were going to take a final exam. The final exam is going to be in 2 weeks. So if I gave you, and there were 100 questions on the final exam, and I gave you all 100 questions right now and let you study those 100 questions, and then at the final exam, I tested you using those same 100 questions, I don't know if you really learned the material, right? Because you've already seen those questions. The right way to do this would be, I'm only going to give you 70 questions to study, and I'm going to keep 30 questions for myself. I'll let you study 70 questions. After you're done studying at the final exam, I'm going to take these 30 questions and give it to you and test you on that. And if you do well on these 30 questions that you've never seen before, then I know you've actually understood the material. And so same idea here with machine learning. I'm training a model on 70% of the data, and then I'm going to apply it to that 30% of the test data. And so all of that's being done here. And once that's done, I'm going to see my results. And in this case, I'm just comparing it. I'm comparing the model on my training set and on my test set. So you can see here, I have my mean absolute error and some just other statistics like relative squared error, root mean squared error. So that's from one algorithm. And this is the results from the other algorithm. So I can take a look at this and see that, okay, maybe one algorithm is better than the other algorithm. And then I have my trained model. Once I have my trained model, now I can go to my predictive experiment. And then essentially, this is now becoming a REST API. So the same trained model here. So for example, here is the regression, the model that that performed a little bit better. And then this is the input to my web service, and this is my output. And so the idea here is now I can use this model. I can send data into this API, and then this data will be used, and then my trained model will be applied to it, and then I'm going to get a result. So basically, the whole idea here is I've done my training. As a data scientist, you want to predict how much that car is worth. You've created that model. But that model is not very useful until you can actually send data to it and get predictions back. So this part of it enables you to do that. So you're taking that model, you're putting it in production into a cluster on Azure, and it's exposed as a REST API. Now you can send data to that REST API, and then you can get a prediction back. And now you're sending these features about the car into the model, and you get a prediction back of how much that car is. And so that's the end-to-end workflow for the visual interface or Machine Learning Studio. So this is a quick and easy way of getting started with data science, visualizing all of the different things that are going on in the process without having to write any lines of code. And so this is one way that you could use Azure Machine Learning. So the next thing I want to talk about is automated machine learning. And so we'll stay with the same example. How much is this car worth? And as you saw, when we try to figure out that problem, as we try to predict how much this car is going to be worth, we saw in the data set that there were lots of different types of features. And then we also saw there were lots of different algorithms. In the example that I just showed you, there were 2 algorithms that we tried out. And even in just those 2 algorithms, things were already starting to get a little bit complicated. It was starting to get a little bit hard to manage because each one of these algorithms has some set of parameters that you have to train in order to get a model that works very well. And so as a data scientist, what you're essentially doing is you're trying to pick some set of features. You could do this in an automated way or a manual way, and then you have to pick an algorithm. So just like we did, we picked an algorithm, and then you have to train it to get some set of parameters, and then you get a model with some performance, in this case, 30%. And then, as a data scientist, you look at that 30%, you say, this is not good at all. I'm going to do it again and again with a different set of algorithms and do another training run, and I'm going to do it again and again and again and again. And a data scientist, you've paid this data scientist lots and lots of money, and this is essentially what they do all day. So basically what you're trying to do is you're taking in all this data, you're trying different algorithms, you're trying different parameters, and you're just trying to get some model that will have some good performance. So with automated machine learning, what we're trying to do is to accelerate that development life cycle. So instead of you as a data scientist having to manually look through all of these different algorithms and figuring out, running all of these training jobs just to get some set of results and trying to look through all of the different results, automated machine learning essentially does that for you. So you give it your data, you give it some set of goals, and you apply some set of constraints, and then it will essentially intelligently test all of these models in parallel, and then be able to come up with some model with some set of parameters that can then give you an idea of the best performance. And so now, instead of having to do all of that work in the beginning, you now have a more intelligent way of figuring out how you're able to go about this. So now you can say, okay, it seems like this algorithm with this set of parameters using this set of features seems to give me the most promising results. Therefore, maybe I can try improving on that. Or I might understand a little bit about this algorithm, and then that might help me do a little bit better. So the whole point here is, instead of having to search through all the algorithms and all the features and all the different parameters in the parameter space, this will get you most of the way there. It might actually do pretty well right off the bat, but at least you don't have to spend as much time on that. And so with the automated machine learning, this can help you come up with a model relatively quickly. The other thing about the models is just to also give you an idea of feature importance. So one of the things that's been important is explainability of models. So for example, if you ask me to create this model and you give me some features and I predict how much this car is worth, I give you a number, right? At the end of the day, the model is giving you a number of basically how much that car is predicted to be worth. But how do you know how it made the decision? Maybe you work with governments and the government doesn't want to have a black box. You need to have some idea of what features were used to actually come up with this prediction. And so the idea is also that it will give you the analysis of feature importance. So at least you can say, okay, in this model, mileage was the most important feature, and other features give you an idea of how much that played into it. And that model was the model that gave you 95% accuracy. There was a model that gave you 70% accuracy, and condition was the most important predictor of that. But that didn't seem to be very accurate. So probably mileage is a more important feature than condition. And that's really what it's saying here. So now you can at least get an idea of what the model is using to make its prediction with model explainability. So I'll talk a little bit about automated machine learning in the in the workspace. So going back to our workspace, you can look at automated machine learning here. And with automated machine learning, you can do that directly here if you wanted to. So you can just create an experiment and then load up your data and then do that directly from the portal without having to write any code to be able to then kick off that experimentation job. So while this is loading, let me show you how to do this with code. So let me go back here into my other machine, and then you can see how it's done with code. Or maybe the internet is, okay, we'll see how fast this goes. Try reloading that right now. You know this is a real live demo. This is not a fake demo, and so you can see that. We'll see how, there we go. Okay, so, so what I did here is using automated machine learning, I'm doing forecasting for orange juice, and in this case, I just gave it some data. I'm trying to predict how much orange juice is going to be sold, and I give it all the data, and then it's basically doing a search across forecasting algorithms and trying to figure out what's the best way to forecast that out. And so let's see if this is going to load, and you can see here all of the, in this case, you can see that it's giving me the results of that, and then all of the different iterations. These are all of the different ways in which it tried to find the best model, and the different models that it tried to use. And here you can see here is the normalized mean absolute error, and I'm going to sort it by having the lowest one first, and so it looks like this model might be the best one here. And so now I have a model. So just by giving it the data, just by giving and then letting it run, it will do a search through all of the different models, different parameters, and then try to see which one has the best result. And then I'm able to get some information about what this model is, and then looking at the different metrics from that run, and then I now have a model. So in this way, this is an easy way for me now to have this model that predicts how much orange juice I need to stock in different stores at different times. And I could do it all just by giving the historical data without writing any code. If you do want to write code, you can do that locally here. So using the Azure Machine Learning SDK, you can see here that I'm just writing Python, and I'm incorporating the automated machine learning package, and this is basically the same problem where I'm doing the orange juice forecasting. And so you can see here, I can view and visualize the data. For those of you who may not be familiar with Jupyter Notebooks, the nice thing about Jupyter Notebooks is I have a little block of code in this cell. I can click run, and you can see that it just executes this cell of code, and I get my results. So in this case, I'm just looking at all the different, just what the data here is. And then, and basically, the things that we did visually through the visual interface, I can do that in code here. And then here, I'm doing the training for automated machine learning and kicking off that run. So the main point here is you can do the same thing in many different ways. You can do it in the visual interface, you can do it through the Azure portal, or you could do it in the using code in the SDK here. So as part of Azure Machine Learning is also the concept of managed compute, or Azure Machine Learning Compute. And so you could distribute your training, and you can do that on the managed compute. And so the idea here is with managed compute, there's a lot of advantages that you can get, where you can schedule your jobs and distribute the data, scaling out your resources, all of the things that you would need to do in a production environment in the enterprise, rather than just doing a one-off job. So you can do all of this with the compute. And so with the dependencies and containers, you use the managed compute, or you can bring your own compute. So for example, maybe you're just doing some exploration and you want to do that on your own local machine. You can do it on your local machine. Then you might want to do that on a virtual machine with more computing power, with more memory. You can do that, spin up a machine on Azure, submit your job there, train it on there. You can do it that way. You can schedule your jobs or provision the CPU or GPU clusters for your training, and then distributing that data over the cluster, scaling up the resources. This is just a nice way of being able to manage all of that with the training infrastructure. When you want to deploy your model, we also have a way of being able to run that model on different types of chips. So we have CPUs on all of these various series of VMs in the Azure family, optimized for flexibility. We have deep learning GPUs, and tomorrow I'll talk about how we're running also deep neural networks on FPGAs in the different types of ways in which you can run your machine learning models. So now we'll talk a little bit about DevOps, and DevOps is just the way in which you're able to manage this entire pipeline and workflow. So we talked about the different building blocks for a data science experiment, whether it's going to be starting with a data preparation, and then building your model, training and testing it, registering and managing it, building it, and then being able to deploy it into production. And so this loop is going to be something that you're just going to keep running over and over and over and over again. You're going to get new data. You might want to do something. You might want to retrain that. And then it's important to be able to make sure that everything still works. So for example, the example that we were talking about, you now have a model that can take in information about a car, and you can predict how much that car is worth. So now you put this into production. Maybe you put it into production for your customer, and they build it into their pipeline. They're getting in data, and they're getting in a result. Okay, everything's great. Now maybe 6 months later, they've been collecting some more data, and they're able to now, you're able to train a more accurate model. So what do? Okay, let's retrain that model and make sure that, make sure that the model has higher accuracy, and now you have a better model. Great. So what do? Are you going to put that model directly into production? I don't know. What if it breaks, right? So how do you manage that process to make sure that nothing breaks in that pipeline? And so the ability to be able to add more data, to be able to retrain that model, containerize that model, deploy that model, test that model, make sure that it still works in that end-to-end pipeline is very, very important, and something that you don't want to do manually, something that you might want to do in an automated fashion. And so we have integration with Azure DevOps and also with pipelines, so that you can manage the pipelines and the flow for data science. The other thing that we have is model management. And so just like code, we also want to be able to manage models. Because typically what we're seeing in the enterprise today is that you may have built the model. So our favorite model right now is a thing that predicts how much this car is worth. It's running in production, and you're getting results, and it's predicting how much these cars are worth. And then your boss takes a look at the result and asks, looks at the result and doesn't believe the model, doesn't think the model is actually very accurate. So then the boss asks, who built the model? I don't know. Where was the source code for this model? I don't know. How about where's the training data used for this model? I don't know. That's kind of what we're seeing in the landscape today, because data science is still a very, very ad hoc process. You have data scientists who are taking in some data, creating and training a model. They're putting it into production, it's running in production, and then they forget about it. They go on to their next project, different set of data, different models, putting that into production, can't keep track of anything, right? We don't have that rigor of software development in the data science workflow. And so that's why this model management service integrated with DevOps is just something so important when it comes to enterprise-grade, an enterprise-grade AI platform. And so I'll go back to the workspace to illustrate just some of the things that you can now have with model management. So here, I have my set of models. Actually, let's start with our experiments here. So my experiments is just the set of experiments, and each of these experiments might have a lot of different runs. So with data science, I have one experiment, and then I'm going to try a lot of different things. So in this run, I'm going to try this set of features with this algorithm with this set of parameters. In my next run, I'm going to try some different features with a different algorithm and then different parameters. And then I might have a lot of different types of runs, and not all of them will be very useful. But one of them may result in a model that is the most accurate. So out of all of these runs in the experiment, I could tag this model is my best performing model. So that's the model that I'm going to register. So out of my experiments, I have a model that performs well, and here I've registered this set of models. So now, in this model, model management service, these are all the models that I care about, and the people in my team who have the right access to these models will be able to access them. So now I have a way of keeping track of them. I have a way of providing access to them. The next thing that I can do is I can create Docker containers with these models. So for example, I have a model here. I can create a Docker image with it. And then I have a set now of Docker images. So these are now all of the Docker images that contain all of the dependencies required for these models. And then I can take this Docker image and I can deploy it to different places. I could deploy it to my Azure container instance, Azure Kubernetes service, or other places where I can deploy this model. So for example, I have a deployment to my Azure Kubernetes service here, and now I can track. So this is my auto prediction model. This is now running in the cloud. It's running on a cluster. It's taking in data. It's giving me back my predictions of how much this car is worth. My boss asks me, tell me more about this model. I don't really believe it. I don't think it's doing the right prediction. Well, let's go trace it. Here is the model running in production. Here is the Docker image that is running. And in this Docker image, here is the actual model. And now with this actual model, I have all of the artifacts required for that model, etc. So now what I have is model lineage. And that model lineage is very important because now I have the ability to be able to trace my deployment to the Docker image, to the model, to all of the assets that were used for that model. And that's why it's so important to be able to keep track of this, because you're probably looking at this right now and saying, why does this even matter? Because we're only showing one example with one model and one experiment. But imagine you're working in an enterprise and there are hundreds or thousands of models, and out of those thousands of models were probably millions of experiments or tens of thousands of experiments that were required to get to those models. And you have all of these different Docker containers and new versions of the model. So how do you keep track of every single version of the model? How do you keep track of all of the deployments? Maybe you run a grocery store and there are 10,000 stores that you're deploying these models to, and each one of those deployments might have different versions. So you can see how this becomes a very big problem in a very big way when you need to manage all of these models, and that's why it's so critically important to have the model management service. And the last thing I'm just going to talk about real fast is also the model explainability, and going back into just the importance of being able to explain that model. And so we also have the model explainability SDK, and so here is, I'm just using the Iris dataset. Iris dataset is a very common dataset that just helps classify what kind of flower this is. So you can see the different types of flowers here. But the idea here is with the model explainability, I can go down here and it could give me an idea of which features were the most important, and then also just give me an idea of the ranked global names. And so now I've built a model. In this case, instead of predicting the price of a car, I'm predicting what type of flower it is. And this is helping me explain, okay, these are the features that were most important in being able to provide and be able to provide the most accurate prediction. And so with that, just to summarize everything that we've talked about, Azure Machine Learning is a enterprise-grade data science AI platform that enables you to train and deploy and automate and manage your machine learning models all at enterprise scale and access with the Python SDK for those of you who love and use Python. Also, we have our codeless experience with the visual interface. We also have automated machine learning to help you get started building that model very, very quickly. And then using MLOps to be able to tie it all together. And then Onyx is an open neural network exchange format to be able to represent those models and also to run them very quickly. So with that, hope you get started with Azure Machine Learning, build your amazing models, and do great things in data science. Thank you very much.